found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
Good morning, everyone, and welcome to WeAreDevelopers Live. My name is Seyad, and we are going to have a full day of interesting sessions about coding the future of mobility. I want to say a big thank you to all of you joining us from all around the world, and also a special thanks to Bosch Austria for making this event happen and also giving us the opportunity to have a glance behind the scenes of the automotive industry and what's coming in the future from this area. We'll kick off the day in a couple of minutes with an interesting interview with Peter Kalt, the General Engineering Manager at Bosch. And then from 10 to 12, we will have a hands-on workshop about developing smartphones on wheels, meaning that we will answer some key technical questions about the automotive industry and how cars are developed, especially, of course, the modern cars of the future. Then, after a short lunch break, the fun begins again at 1 p.m. You can not only join online, but also in person in Vienna. We will have 3 sessions with talks about cybersecurity, machine learning, and software architecture. We will have food, drinks, snacks, and also a music after the event in the evening, if you are joining us in person. Then also before we start, as always, you can engage with us in the chat with the speakers. You can use the chat besides the live stream and also ask your questions with the small ask button. We will have a Q&A session after each talk. So please feel free to engage and also respect our code of conduct. Here's a small video. So then let's start with the first session. It's a pleasure to announce our guest for our Coffee with Developers session. He has been a developer since the late 80s, working mainly on software and embedded systems. He has been part of the automotive industry for many, many years and at the forefront of the transformation in this industry. He is today the General Engineering Manager at Bosch Austria, leading a huge team and working on huge projects. Please welcome on stage Peter. Hi, Peter.
Hi, everybody.
How are you doing this morning?
Yeah, good morning. Thanks, Seyad, for giving me the opportunity to give you a little insight here now.
Cool. Thanks for having us. Peter, just to break a bit the ice, what was your first computer actually?
My first computer, it was during the HTL. It was an 8085, where we made some small programs during learning software in a very rude manner at the early stages when the microcontrollers really started up. But at that time also, just to give you an insight, we also were still working in communication engineering on some communication network based on relays and other stuff. Yeah.
Okay. That was technically a correct answer, but what was your first personal computer?
My first personal computer. After HTL, when I studied technical physics, I worked also as an apprentice at IBM in Vienna. And at that time, it just happened that the PC first time was introduced in the market. And I was part of a 3-person teams of students. We prepared for the dealers at that time the replacement and spare parts. And we also trained the engineers for repair of PCs. And that time, I also got my first PC ever. It was an 8088 and really great. It had a 10 megabyte hard disk.
Okay. And what did you do with it?
Yeah, on one hand, working for the company. On the other hand, I made some programs also for my studies. I worked on some least squares fit programming for magnetic material, but also to earn some money for my life. I worked in the evening sometimes as a barkeeper, offering for some parties cocktail mixing. And also I set up a first database where I stored all recipes for cocktails, but also the materials I need so that I can offer to the customers a limited set of liquors and drinks they need to buy when they have to provide a party for about 50 or 100 people.
Okay,
so this was like the first programming.
That sounds like a fun program. For the younger audience who is watching us, what kind of programming languages or what's the technologies behind when you did this database?
The first was assembler for sure. Then I think DBase was one of the first databases. In parallel, also Turbo Pascal I enjoyed, and later on Microsoft C.
Okay, cool. And I mean, how did you actually develop?
Sorry to interrupt you. Yeah. Also, on the university, I really enjoyed programming in Fortran.
Oh, okay. But we will come back later a bit to these low-level programming languages. But yeah. How did you actually develop your passion to become an engineer?
I think from being a child upwards, I was interested in understanding nature and physics and how the world is running. And I learned that with analysis and mathematics, I can understand a lot. And if I want to get some solutions, some improvements or things you can't do by hand, I started programming there. Yeah. And yeah, I enjoyed it. And afterwards in my career, I was allowed to work on a lot of really interesting products. So I think the engineer is saying if it's turning and running and you can touch it and it's a real product which you can see driving on the road, this makes fun. Yeah. And also, for instance, if you are working, especially in the automotive here, you get access to prototypes, you get access to new functions, which are interesting, really funny stuff for a developer. And working here is really making also very proud on being part of solutions to improve, on one hand, the comfort of the driver, but also on the other hand, the overall sustainability of this product.
Yeah, I mean, that's interesting to hear because, technology obviously has changed over the decades a bit, but the motivation for developers has kind of stayed the same. It's always the same answer, like how did you develop your passion about it? And it's always it's not only fun, but you want to change a bit the world. You want to understand how the world works. You want to, think a bit logically and so on. Would you agree with that it's like the motivation behind is something that we all have in common, being software developers?
Yeah, I would agree with that. And I think it's generic for technicians overall. It's I have an explanation. It's just a kind of playing which remains stable even if we become grown-ups. Yeah, we want to play, we want to learn, we want to check what is the nature around us.
Yeah, absolutely. Well, preparing, I mean, you touched already base on the general topic of today. I mean, obviously, we are going to talk a lot about the automotive industry because the event is called Coding the Future of Mobility. And while preparing for this talk, I learned that, when you talk about Bosch and you work at Bosch, then people mostly would maybe first think about some products and tools that you use in the household and so on. But while preparing for the talk, I actually learned that you actually have 30,000 developers all around the world working on smart devices, IoT stuff, artificial intelligence, connected products, and so on. And I also learned that basically Bosch is the largest automotive manufacturer in the world, because every modern car has at least one or two pieces of Bosch inside. Is that, first of all, is that true? I assume it. And secondly, how does it feel like being a bit in the background, but knowing that it's like you shape the future of mobility together with your team?
Yeah, I think it's a local culture of Bosch, also in the former times, that a lot of innovations in the car has been sold more than Daimler introduced it or VW introduced it, and Bosch was only staying in the background. In the meantime, it turns a little bit, but for sure, we are present in every car, either with combustion engine or with electric transmission or with any kind of powertrain. You will find Bosch everywhere, and I think there's no need to make it I think like advertising. So our OEMs are selling the cars, but we are behind them and we support them, and we support them as well in development, but also in manufacturing or in logistics.
Mm-hmm. Yeah, sounds like a cool industry. How did you, you have been working for Bosch, I think, for 30 years or 28 years right now. So
28,
from 93 onwards. What fascinates you about this industry, especially? Because usually you might think, you make a few job hops, have a look into other industries and areas. So why did you stay so long in this area?
Yeah, I think during my career, the first step in was for sure that it was very interesting at that time. Engines have not been so clean, and we were really proud. The whole team was proud when we could work on improvements there. I remember we had a skiing session, and every member of the team wore a T-shirt where we really were proud that we are the team improving some engines for a dedicated OEM. And this really was fine for us. Afterwards, I think in Bosch we have a lot of innovations until now. Electrical engines, electrical powertrain, a lot of additional stuff is coming. In my personal career, it was also interesting that I could develop first for sure products, and being proud having these products really on the road. And later on, becoming a manager, I was proud to get the chance to develop projects or develop teams, so that we really shape our future not only on the electronically or technically way, but also get the chance to work on cooperation models, on business models, or we are an international company to work on international cooperation. Also, this is challenging, and it's a different level of challenge, but this makes the fun, and that's why I'm here still.
Building cars 30 years ago might have been a bit different to building cars nowadays, because many also say it's the future cars, or today's cars are actually smartphones on wheels. There is like thousands and tens of thousands lines of codes in them, and the chassis and everything else basically doesn't change that much. And you've been also at the forefront of this of these happenings. What would you say have been the biggest changes over the last decades for the software engineers and engineers in general?
Yeah, I think I would mind on two big changes. The first change was that after getting a range of size that we have in the meantime, some 100 million lines of code in the car, safety and security became very much important, and this had a big influence also on the working processes. So I think for a safety relevant product like the car, software also gets a safety touch. And the second thing is, when I check the development, in the first time we were really proud to be the hard register close and CPU close coder. Then there was some kind of further developing towards model-based developing like MATLAB and so. And I think 10 or 15 years ago, everybody told us you will not need the software experts again, because graphically modeling and painting some structures on the screen will be sufficient. Yeah, and yeah, I did not like that, but I had to accept it. But some years later, it turned out that the needed power, the needed functionality is so high that you will not succeed in every case if you just do graphic modeling. So now again, I think the last 7 or 8 years again, we come back to the situation that the real software expert who is looking into registers, who is able to program really good stuff, but needing not much resources, not much calculation time, this again becomes a highest value and appreciation. And this is, I think, a good change, because this is bringing the human, the expertise again back into that product, not only models. Yeah.
Mm-hmm. Okay. I mean, when you said safety, I mean, this is also something that we need to consider. Safety 20, 30 years ago was basically connected to safety in the car, you know, when you have an accident, actually, that you stay safe and so on and so on. And nowadays, safety is maybe a bit more. It's also kind of security, cybersecurity, you know, preventing the car to be kind of hacked or so. Can you tell us a bit more about the challenges from there?
Yeah, on one hand, it's especially regarding the hacking, it's a continuous competition. I think there is in the world the same number of engineers working on hacking the cars, like at Bosch or other suppliers working on protecting the software. So it's a continuous further development, and everybody in the world is searching for some doors to step in and to start tuning or something like that. And we are fighting against that and bringing solutions for that. This is one thing. The other thing is that, especially for internal safety, so that you avoid an unexpected acceleration of the car, for instance, or something like that, there is also a high need for really working very consequent, following processes, following separate norms, and also working in some kind of safety models that standard software developer would not know. Yeah, so there's also high expertise necessary, and it's not like in an airplane. Yeah, for sure, it's not so administrative like in an airplane, but it's some kind of medium, big knowledge needed, and several additional processes and tools needed to really create safe code.
Mm-hmm. Yeah, you mentioned also the topic about graphical modeling, and we also had a short touch base on low-level coding languages. And I mean, I had the feeling like 10 years ago that, you know, developers coming from the university or making their first steps, they all wanted to kind of, you know, have more to do with high-level programming languages and not moving around, you know, the registers and thinking about memory and so on. It was like kind of very uncool. And to be honest, I mean, I learned assembler as well in school and I really didn't like it. But in the past couple of years, recently actually, I have the feeling that, you know, with the rise of these smart devices that everyone can touch and program and so on, and with IoT applications, with also, of course, the automotive industry moving forward, that it kind of has got a second spring, like people are going, or developers are also becoming again more and more interested in embedded systems and having a bit of knowledge also of low-level coding languages and so on. Do you see this also in your teams or when talking with tech talent?
Yeah, for sure, we see it. I think the complexity has risen, and the controllers or the CPUs are still limited. And there are some parts, I think, where this graphical programming really makes sense. but there are a lot of parts, especially in the infrastructure, communication, hardware-related software, safety, and others, where you really need very good and excellent code directly manually programmed, because otherwise you would never solve the problems with an existing controller. I have a good example. I remember a colleague of mine some years ago. We had to find a solution for measuring out a sensor, a PWM signal by frequency, by ratio of the PWM. If you would make such a feature in a graphical language, you would create 100 kilobytes code and a runtime of some milliseconds. And a good programmer needs about 15 lines of assembler or C code, producing 30 bytes of code and being able to measure microseconds. And if you take this example, and in a car you have about 100 or 1,000 of use cases like that. And this brings down the need that we really have good coding expertise and also the knowledge, not only in the central computers, but also distributed to all sensors and actuators, because all of them become intelligent to solve additional problems, especially in automated driving, for instance. If you would calculate everything in a central computer, it would be much too much. So take the SoCs of Mobileye or Qualcomm. Also here you have really high software and really efficient code already at the device where the videos are analyzed.
Yeah, I mean, you mentioned like intelligence in cars and autonomous driving. How does this actually work for the people who don't know that? Like, everyone is talking about autonomous driving, and there is some car manufacturers also offering it at some parts in the world. But how does that actually work? Is there like a mainframe somewhere where all the calculations happen, or is it happening in the car? What's the technology behind, or how does this actually work?
There are different approaches. I think you have at first the sensors, radar or video cameras, and they need already a very fast evaluation of their signals. And I think they then transfer situations or some codes, what happens around the car, to some electronic controllers. Possible until now, these controllers have been only designed for that purpose only. And it's at the moment from the electrical architecture a little bit changing, so that intelligence would be concentrated in some central vehicle computers in future. And these central vehicle computers really need high calculation power, but also, they rely on having a good pre-processing of all inputs they get. And in parallel, I think there is no mainframe behind. So you need to be able to act as initially as something happens. There's no time for some cloud communication if a person is crossing the road ahead of you. So you can't say, sorry, I hurt this person, but I did not have internet connection. So everything must be on board. You must be able to act. But for sure, you have some cloud solutions where you get some additional data. Like if you drive on the road and there is some accident in front ahead of you, possibly that data can be transferred to you, that the car reduces the speed already. So this might run offline or in a cloud, but the main activities of driving and reacting on the surroundings has to happen in the car.
Okay, that's interesting, because I mean, it's also again like something about safety and security and so on. Because imagine like 2 days ago we had this case with Facebook services being down and a lot of people around the world crying. But I hope that nobody died because of Facebook being down. But imagine the same thing like in the automotive industry, if there is something in the cloud or whatever, and suddenly all cars stop, or some kind of worst case scenario, this could be kind of a very interesting or sad occurrence. So it also kind of shows like that's maybe a bit more tricky to develop stuff in the automotive industry than just like like social networks or whatever.
I'm not the expert, but from my feeling at the moment, I think these supporting functions, giving some information what's ahead of the car, might come from the cloud just to improve comfort. And on the other hand, I think at the moment the use case is also, as all companies working on automated driving are at the moment in the learning phase. Yeah, so a lot of situations at the moment transferred also to the cloud just to enrich the test cases. Yeah, because there happens a lot of things, and if something did not go so fine, then the test cases need to be enriched, and all these companies have millions of test cases to run offline through their development to train the software to react in the right manner, and this is a continuous process at the moment. Compare if you test an automated driving in US or in Germany, yeah, you will have a lot of drivers really keeping all rules. Yeah, so the software might have an easy job. Compare it to a drive in Cairo or in Bangalore. Yeah, you cannot trust anything. Yeah, and I think the same car, it would not move in India. Yeah.
I think it's a lot about getting this training data, right?
Yeah.
And what I learned also, it's quite interesting, like, for all the ones who are watching us, we are always solving these captures on some websites when we register or log in somewhere, where you have to say like, hey, please mark the pieces where you can see a fire distinguisher or a crosswalk or a bus or whatever. And actually this is used to basically have input data for autonomous driving and so on. And that's also quite interesting how we all kind of are part of this of this training actually without actually knowing it.
Yeah.
Peter, when we talk here like in this way, what is actually your day-to-day job, or how does your usual day look like as general engineering? I assume you're not coding yourself anymore.
Only in my smart control of the house. Yeah. Okay. Yeah, still I'm coding, but in the office, my usually I have the luck that I have on one hand the responsibility for a big team in Vienna. On the other hand, I also am responsible for a dedicated OEM, a German car manufacturer. So yeah, there happens a lot of meetings to organize us, to make the budget planning, to take care for the staffing. We are hiring a lot of people in the next time because we have been very successful. This needs also to be organized from the financial, but also from the HR point of view. Here I do some support. I'm for sure responsible for my own customer projects, for keeping the budget, checking the turnover and the earnings, and optimizing for sure if something is needed. And finally, as if you have a lot of projects, also some escalations might happen. So I have to stay in close contact with my customer to to watch his voice or to listen to his voice and take care that whenever he is not feeling fine, that we work on some improvements or clarify. Or just at the moment, we are very busy with these problems in supply of semiconductors. So there is the need that some products needs to be redeveloped to change to some other components which are available. This makes no fun because it's already a final developed product. Nobody would try to touch it, but we have to do it. And together with the customer, we organize that on one hand, this development happens. On the other hand, the logistics and validation happen. And on the third hand, we need to introduce the product in about 20% of the usual time. So there's high effort in making everything right to bring that into production at a time where the parts still are available.
Okay. That sounds quite challenging. But besides that, what are the other projects you're focusing right now on? Like, what's your team working on? What's the challenges? What are you developing? Like, also for the future, especially. I think.
We have on one hand our standard business, which we have been working until now. At the moment, we are really growing fast, and especially growing towards electrification. So we have not only combustion engines controllers, but also fuel cell control is in development. We are working on inverters for some electrical powertrains. We are working on e-axle products. And especially, as I mentioned before, the new electric architectures need some new components like central computers, vehicle controllers, or some zone controllers which take responsibility for a part of the car. And all those products are also in development in Vienna.
That's interesting. Also for the people watching us right now, so stay tuned. Also at 10 a.m. we are going to start our workshop exactly also about the topic of the software architecture and the transformation of electrical architecture in the automotive industry. So the workshop is called Developing Smartphones on Wheels. So stay tuned for that, starting in 13 minutes. But yeah, let's get back to this discussion. Peter, what do you think? Will the future of cars look like? Or how will it be like to drive with a car from A to B, let's say in 15 years or so? How will it be different to today?
Yeah, I think in 15 years, it's realistic that we really have automated driving. I don't believe that we will have it in 5 years, finally. Yeah. So I think we have some companies which are running ahead, yeah, accepting some accidents, but yeah, it is as it is. I feel really trustable on the market, and also with a clear legal situation and a clarified situation regarding insurance and other things. I expect this will be available in 15 years. Yeah. So
do you also think that the kind of the business model or the ownership of cars will change? Like today you own a car, but with shared economy and so on, basically also you can already rent it for a couple of minutes also. Yeah. Will that change? Maybe not in 15 years, but let's say if on a longer time scale, that we basically will not own ourselves the cars anymore, but rather, share them with others and have some other models.
Yeah, I think this is not a linear calculation. So there's not only one argument. Some years ago, everybody told this car sharing will become very popular. And what we see is just having a pandemic, everybody likes his own car now again. Yeah. So there might happen some situations. And finally, yeah, possibly if we really make this continuous pressure on reduction of the combustion engine, I think then it will become very important how is the offer of charging stations and infrastructure, especially in towns. Yeah, this will have an influence in the usability of cars. I think in on the countryside, yeah, if everybody owns a house having his photovoltaic on the roof, and it is easy to have an electrified car. Yeah, this will be for sure not an issue. But the solution for bigger towns, I'm interested how it will look like, and also whether it will then be still usual to own a car, or it will just not be possible because everybody will say, sorry, no chance, you have underground, you don't need a car.
Yeah, that's true as well. So looking forward to see what will happen there. Another question for the younger people in the audience also, like if you would like to start a career in this industry or work as a developer or engineer in this industry, like what is the possibilities? I mean, there is so many things, like, from the low level, like working with assembler on some electrical parts, embedded systems and so on, to maybe high level developing infotainment systems for the car. What's kind of the possibilities to get the career started there?
Yeah, I think for every interest we have good places. Yeah, so there is in every product there's a good mixture needed. Yeah, you need on one hand that the low-level programmer understanding registers. You need the high-level function developer understanding physics and processes. Yeah, you need some tooling expert because especially if you have a lot of manual coding, you can improve a lot if you are experienced in Python and automating some stuff this is very important and can make a team speeding up by a factor 2 or 3. Yeah. So I think for every discipline we have places. Yeah. This is the answer. There's no limitation because we have really software scientists. Yeah, we are working on data lake. We are working on artificial intelligence. We are working on tool improvement. We are working on our development environment to improve it. And finally, we are also working on physical functions where really a physician or a machine engineer can contribute.
Okay, that's interesting. And how do you find the tech talent? I mean, you said you are looking for like couple of hundred of people in the workforce in the next couple of months and years. Like how do you attract them? What's your offer for them?
Yeah, I think on one hand, methodologically we are present in the media and trying to work on every channel to reach associates. On the other hand, I think we have also a good renommee. So working for Bosch is, as I know, and I see the attrition, and for sure some colleague left us in the past, but I'm really happy some of them also came back again because they've seen that the grass and the neighbor is
not green,
same green as the Bosch. Yeah, so really proud of is that we have a very top team spirit, and also a good social support from the whole company. So it's not like usual other companies where you get a very high salary, but nobody tells you that it's expected to work until 9 p.m. Yeah, so here we try really to keep the standards, to work in normal rules and to get the things done with some kind of normal work. For sure, if we have also task force projects, yeah. But I think challenges you have to accept, otherwise you will lose business. Yeah, but this is not the continuous load for all.
Yeah, that sounds realistic. I mean, maybe now with the pandemic, it's a bit different, but I mean, you don't only have engineers in Vienna. I think you have here a team of 800 people, 2,000 people or something like that in Vienna, and building up something also in other areas of Austria.
Yeah.
But in general, I think you have people all over the place. So is there a possibility, to, if you don't want to be here anymore, to switch to another country?
We have a standardized international development network. So especially in our project, for instance, we have colleagues in Vietnam, in India, in Romania, also contributing or even taking full project responsibility for our customers. And this has been really established in a good manner. That was also the reason that after having the pandemic and everybody during the shutdowns needed to make home office, we were continuing our projects without any influence on the customer. Even our labs are fully remote controlled. So a Vienna colleague can test his software in India, and an Indian colleague can test his software in Vienna without any restriction. We just needed to have some people to maintain the labs, and if there's some change needed, to do that manually. But hundreds of people can contact the remote testing benches and do its work. So for the international work, we are really well prepared, and it's also on one hand not only a good cooperation. Bosch also likes to have people seeing something of the world. Yeah, so getting in touch with other cultures, living for some years then and coming back is very, very pushed by Bosch also. Also, I have been some years in other country working on similar stuff. I've been in Germany and have there been responsible for a platform project where we established a new controller generation. And this was really, really a good learning for me, and also for the networking. I think I'm still now having profit of that because I'm really well linked to the colleagues worldwide now. Yeah.
Yeah, that's good to hear. I mean, talking about yourself, you said that you are setting up at home some smart devices and smart home stuff. So what does a guest at your home can expect?
Yeah, you can expect that I have a chicken stable, I have a pool, I have some animals. The temperatures are visible in a central screen. All temperatures are controlled. The windows will open if it's getting cold during the night. The shadow will go down according to temperature and daytime. So I try to have a passive house where really without waste of electrical energy, I can cool it down during the summer just by having passive activities. Yeah, and this everything is electrified and controlled by daytime, by temperature, by intensity of sun, and for sure even the windows will open during the night to cool down.
Oh, that's cool. And you made it yourself, or you had some help?
The parts I bought, but the programming I do by myself. Yeah.
Okay, that's interesting. That's interesting. So if anyone needs an advice on how to, make your home smart, then Peter is definitely available for a small chat. Okay. I see we only have a few more minutes. Yeah, maybe Peter, I would give the stage a bit to you. Like, is there anything else you would like to share with the audience? Maybe give some pieces of advice to tech talent and to developers, how to build a successful career and so on.
Yeah, I think how to build a successful career. Generic answers usually are generic, so I will try to make a proposal. For me, what was important for myself, I will tell you. Yeah, I think being authentic is very important, because at least during the next 20 years you still will cooperate and work with humans, and I think the way you treat them will have influence the way back they treat you later, if your ways again are crossing. So be authentic and be what you are. Yeah, this is a very first rule. The second is, I think, flexibility. Yeah. An old saying from mine is, nothing is as stable as the change. So things which have been true or have been right 2 years ago now need possibly to be optimized. Yeah, and you can insist in having everything fine and no changes, and swim against the stream, or you adapt and learn to live with the changes and with questioning everything at every time, and just searching for the improvement, because in every case you will find anything which is better. Yeah.
Yeah. And okay, that's good.
Yeah. Yeah. And the third is, I think, some technicians behave like a sleeping beauty. Yeah. So they want to show their power if they get some good offer. Yeah. And my learning is, don't behave in that way. It is fully the opposite. You show first power and then you get the award. Yeah.
Mm-hmm. Or the offer. Okay. So first deserve.
Yeah. Yeah. The world plays tit for tat. Yeah. And you have to start.
Okay, that's good. That's good. So actually, like, to sum it up, it's stay authentic. That's very cool. I like that. Like humility and so on. Is always like also a good advice. The second one, the flexibility. Like how did you say, like the only stable?
Nothing is as stable as the change.
Yeah, exactly. That's a good sentence. I need to remember this and write it down. And the third thing is actually work hard and deserve the glory, right?
Yeah.
Yeah. Good, Peter. It was really a pleasure talking with you. These 45 minutes really passed away like nothing. We will see each other again actually in the afternoon at our event. So happy to see you then again. For the audience, we are going in a very, very short break. just that you know. But stay here. We have a workshop at 10 a.m. about electrical engineering and developing smartphones on wheels. And also, please make sure to join us either in person in Vienna or online at 1 p.m. again for our afternoon session. Peter, thanks again for being our guest. And see you later again.
Yeah, thanks, Siad. Thanks for giving the opportunity. And to the audience, feel free to ask. I will be available also in the afternoon. And if you have a dedicated question, I will for sure try to answer.
Perfect. So see you later. Bye.
See you. Bye.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now. found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
So, welcome back, everyone. I hope you enjoyed the break. I hope you grabbed your coffee or tea. And we are here now live with Hans and Konstantin. Hello.
Hello, good morning, colleagues.
Good morning, good morning. So we are going to have a workshop which is called on developing smartphones on wheels. Can you tell us a bit up front? What is it about?
Yeah, for sure. So actually we are talking about the biggest transformation in the automotive industry ever seen. This digitalization is coming into the vehicles and into the mobility world. And this will be exactly our focus for today. And we will work on some use cases for this new mobility world and try to elaborate at least a rough structure of an MVP we can think of. And we will do this on real-world use cases, which are already out in the field or in advanced development right now.
Okay, perfect. Before we start, there is some technical stuff. We are using a Miro board. So we are going to post the link to the Miro board in the chat, and you can also see the link on the screen right now. So you can join there as well during the workshop. And yeah, then I would say, Hans, Konstantin, the stage is yours. Have fun and see you later again.
Okay, thanks a lot.
Thank
Great. Siad, thank you for your introduction. And a warm welcome and servus to all of you out on the screens. I'm really happy to be here with you and have the opportunity to discuss with you and work with you on aspects of the future of mobility and the digitalization revolution which is coming into the vehicles. So I'm really excited about it, and I'm really glad to be here with you. Please give me the opportunity to introduce ourselves here. So Konstantin and myself. My name is Hans-Jürgen Eidler. Just call me Hans. I have 20 years plus experience in automotive industry and general aviation in different roles. I was a hardware developer, a software developer, function developer, software tester. I was project lead, team lead, a product owner, and now a business. Now I'm a business developer for software in this new vehicle and mobility world. We'll see that later on. Yeah, during this journey, I had the opportunity to learn a lot of what does it mean to have the digitalization coming into the vehicles and the mobility ecosystem at all. And this is exactly the thing we want to talk about today. So, Konstantin, may you also introduce yourself shortly?
Yes, sure. Thank you, Hans. I'm Konstantin, and I'm fortunate to work after finishing my PhD at Vienna. I joined Bosch and first worked on localization. And since 2019, I'm happy to work together with Hans on vehicle computers. And I'm a part of a software team. And our primary goal is to develop prototypes for vehicle computers, which will be found in cars in 5 or 10 years from now.
Okay. Great, thanks a lot. So before we start with the content, first things first, let's talk about some organizational stuff. Sead already mentioned we'll use Miro, the tool, for the presentation as well as for the workshop part. We will have then a tryout session for all of you to get familiar with the tool. So we'll step into this shortly. If you have some problems with your live stream, then just try another browser. At least for myself, the Chrome worked well. Also, one hint, we will use the Miro chat function. I will show it to you later on. Also for, let's say, ad hoc Q&As. So if you have some questions which needs to be answered, use the Miro chat function. Konstantin and Manuel, another colleague of mine, are here to instantly answer your questions as far as possible. But don't be concerned. We will also have a Q&A session, a dedicated one, whilst the workshop, to give you the opportunity to get your questions answered properly and in depth as needed. So yeah, then I think we are more or less through with this organizational things. I will step into the Miro board. Hopefully you can all see my screen. We are here. And so let's have a look on the agenda. What can you expect for today? So right now we have, we are in the middle of the check-in already. So we are obviously in the get-together. We will then afterwards check the usage of the Miro board. So to get familiar with the tool, see if it works properly for you. And then we start with the answering of some intro questions. So to get a warm-up for yourself and also have at least a first touch with the topics we will talk today. Then I will give you a short overview in form of an impulse talk. What are the mega trends we are facing now, right now in the world, and what is the impact on the mobility industry as a whole? Don't be concerned about it, will be a short one, but I will give you an intro on that. And then we'll step into the workshop. We will introduce to you 3 real-world use cases we are right now developing at Bosch. And I will propose it to you, and we'll do a voting afterwards to select the favorite one from your perspective, and we will work on this favorite use case from your side in the context of a possible MVP with some aspects there. And afterwards, as promised before, we'll do a Q&A session to give you the opportunity to get deeper into the discussion and in the understanding there. Then we are planning a short coffee break and all the biological things needed. And afterwards, we will do a wrap up of the things we have discussed so far, and move then over into a short introduction of the actual business unit we are in there, XC, and what we are doing there exactly, also from a technical point of view, as well as a generic view on Bosch to give you some guidance where you can locate ourselves there. Maybe you know Bosch just from the dishwashers or the washing machines or such things, so that you have a little bit more broad picture on that. And afterwards, we'll also show to you what could be your contribution and which kind of team and team members you could expect here. And then, we'll do a checkout, which shall give you the opportunity to reflect today's workshop and the results we generated there. And out of that, I think we have a tough schedule, a lot of content there, and I'm really happy to have you all here and to start with our workshop. So then I think we can jump in. Just for you, hopefully Miro is already working for you. Okay, actually, I see there are just 7 persons in Miro in the live stream. Gary, how much people do we have there? So obviously we have some problems.
We do have 45 people joining.
45, okay. So please take the Miro link, which was presented in the invitation mail from WeAreDevelopers. I guess it's also shown there on the live stream. Yeah. So just click on it, and you should be directly guided to the correct Miro board session.
Das ist wichtig, weil sonst können Sie es nicht arbeiten.
Ja. Ich sehe oben diese Leiste nicht mit den Personen.
Sind ja vorhin noch 9.
Okay, are you actually trying to enter the Miro board? So, okay, so how much people do we have already in there in the Miro? 13, okay. Then I think we will start, and all of you are welcome to join the Miro board also later on. please just use the link as mentioned before, which is provided by WeAreDevelopers. So just to give you a rough overview where we are, here in the Miro board on the right side, you have this button here. Sorry. And you can use this to navigate. Just collapse this, use this map, and then you have here an overall map where you see where you can see the overall session boards. And again, just to scroll here out a little bit, you see also the agenda structure here reflected accordingly as presented before in the agenda. So we have here this pane 1 for the check-in. We have here the impulse talk, the slides. Then we have here our workshop part. Then the wrap up and the touch points, as well as our checkout. So if you have the feeling you get lost, just use this overall map to navigate accordingly. You can also use here on the left corner of Miro, there is this icon bar, and you can use here this button here with the frames. And then you can also easily navigate with clicking the appropriate board to navigate here and there. And yeah, this is already our first board we have discussed now. Here this is explained. So if you need some guidance or help, also refer to that, or just post an according question in the Q&A at Miro. This leads us to the next point. You have here this chat function. Also in this icon bar, you can click on this and use the chat function accordingly. So then, hopefully you are ready. We have just mentioned it here just to be sure and on the safe side. Don't unlock things which shall be locked. Otherwise, we could end up in a mess there in the boards. So thank you for your collaboration. And then I think we can move over to our first working board. We are calling it here Play Space. So to get familiar yourself with the tool and to try out how it works. So we have there some explanations. So you can easily add some sticky notes here by clicking on the corresponding icon, which I cannot find right now. And make here some sticky notes, change the color of it, just try it out. You might also do some bulk operations there if you have more than one node to be generated. And you can also format the format accordingly, change colors, the fonts, the alignment of the text, and so forth. And second, here on the right side, you see there is a grouping functionality, and you can also upload images, sketches you generate, or what else here accordingly. So now we have foreseen to give you just some minute to do a quick familiarization phase with the tool, try it out, play around with it, and have fun with it. I just start the timer here so that we have an overview where we stand right now.
Noch das Navigieren zu das Display, dieses Display, der zweite Link. Ja. Der zweite, den da. Ah, genau. Jetzt hast du wieder die Icon.
Ah, okay. Mhm. So I give you some time to play around.
Das ist wichtig, dass wir es jetzt verwenden, weil danach im Workshop, das verwenden wir ja, also muss man sagen, spätestens beim Workshop nachher teilen, müssen wir es dann verwenden und reingehen.
So time is over. Hopefully you are well and fit with the tool. So you can also give some reactions here. So thumbs up or heart or whatever. So you can also give instant feedback like this. Okay. So if it's fine for you, I would move over to the next step and start with our check-in board, our first working board, where we will try to answer some questions. First one, just to get an overview, who is here? What's your favorite dish? What is your preferred one? I brought everybody now here on the other board just to be on the same track there. So we'll work now on 3 questions. What is your favorite dish? Then the second might be an interesting question. I'm eager to see your answers. Then the second is, why are you here? What's your motivation behind? What's your interest? What's your expectation for today's workshop? And what's your intention? And the third question, describe the car of the future in just as low as 3 words. What's your association with that? What do you expect as a user, as a developer, also as a member of the society from the mobility of the future? I will give you 3 minutes to answer the questions, and then, or maybe 2 minutes, and then please start with it, and then we will walk through it together.
Da hat einer in den Kommentaren geschrieben, anstatt in den Chat. Da muss man dann nachher nochmal einen Verweis machen.
Okay. Danke.
Passt das so jetzt so?
Ja. You might also create new nodes or copy the existing ones, and you can place it on the boards wherever you want, just as a hint. So 5 seconds left. So time's up. So thanks a lot for your answers. So let's have a look together on it. So then the first question, your favorite dish. Dolma, okay. To be honest, I don't know it. Maybe you can give a short hint in the chat what it is. Okay, then we have also some classics like pizzas, hamburgers, great. Sushi OFC. Oh my God, I don't know it again. So blame on me. Avocado, yeah. Lasagna, bowl, fries. Great. Dolma, Google. Okay. Yeah, I have to Google. That's correct. Okay, I will do it afterwards. But thank you for the lesson. Then second question, why are you here? I guess that's an interesting one too. Yeah, state of the art, future developments. Yeah, I think this is a very good motivation behind. Some insights on future cars and Bosch. I think, I hope we will fit your expectation today. Find developers for crewnew.com. Okay, again, I guess I have to Google it. Curiosity, I guess that's a very good motivation to get news. Yeah, big fan of Bosch, great. Would be interesting for which kind of products of Bosch, maybe the consumer goods, which are really great, or even the mobility and automotive stuff. We'll have a deeper look on today. For school, yeah, to get some inspiration. Yeah, I guess hopefully we can fit this. And then, oh my God, that's a little bit small. I'm a student, have to participate in international activities. Yeah, I guess international activities is something which is very important here at Bosch. We'll also have a look on this. Yeah, then what are your expectations on the future of mobility? Let's have a look on this. Electric flying safe, yeah, is a point which is coming up. Automated urban aerial vehicles are a new mega trend, will come also with the trend to the urbanization. We'll see it later on clearly. Bosch is also working on general aviation stuff. I was for myself 4.5 years general aviation, and I worked there together with Bosch on a piston engine project. So yeah, Bosch is also active there. Self-driving is a huge issue. We'll see it there. Safe, efficient, well-designed. Yeah. And the design has different dimensions. This is a very important point. We'll see it there. Hydrogen is a big upcoming topic. Bosch is also involved there. Safe, elegant aerodynamics. Yeah, aerodynamics is also crucial for efficiency. Safety for automated driving. Security is also an aspect of safety. Electric safe lean, yeah, goes exactly in the same direction. Thank you for that. And what do we have here? Electric, easy to use, yeah, usability. I guess it's a very important point, and those are a differentiating factor for the future. Availability, yeah, but maybe you don't need to be the owner anymore. Autonomous, safe, environmentally friendly. Yeah, it goes exactly in the direction we also see there. Thank you for your comments and your contribution. Yeah, I guess that's a very good starter for the things to come there. So this would be now the second part. We'll move over to the mega trends. The mega trends we see there out in the world and their impact on the mobility world. So I will, as promised, jump into a short presentation. Where do we stand? We have there, just make it a little bit bigger for you. We have there a lot of global mega trends. I guess no one of those things is new to you, but at least I want to spend some time on that also to reflect what does this mean to us here as a part of the mobility industry and also to us as humans. The first mega trend is connectivity. So Konstantin digged out the number of 40 billion connected devices by the year 25 there. The mobility sector will be one of the major contributors to that with a lot of new use cases. Some of those have a glance view on that today. But this is, I guess, a mega trend, and new technologies like 5G and such things will even accelerate it. Then we have the urbanization there. We have already more than a half of mankind living in cities and mega cities, and this trend will accelerate, at least on a global level, even despite the contradictory trends we see right now out of Corona. But this will be there. Yeah, just to get the info, I should bring everybody to me again. So we are here on this board. You can also click on my icon there to follow me directly. Then you are always dedicated to the point where I stay. Next mega trend is demographics. We see there, especially in the industrialized countries, the situation that we are having a lot more of elderly people. So this raises new questions: how to include them in the mobility, how to keep them mobile in a sustainable and also a safe way. And then last but definitely not least, the energy and climate discussion. I guess everybody knows about it. We are in the middle of a huge discussion ongoing that more and more political organizations are concerned about the situation we have. We have to reduce the CO2 emissions drastically in the next years. And this is now more and more leading to new rules and regulations in the European Union. It's discussed accordingly also at China, US, and all the other important markets. So this has a lot of impact there. And Bosch is trying to actively shaping these global megatrends and derive out of that innovations like our vision is invented for life, Technik fürs Leben, to make solutions which provide also solutions and way forwards to tackle those trends. There are some words already mentioned here, some buzzwords like electromobility, efficiency, driver assistant and automated driving, connected. And those things are reflected in the overall strategy of Bosch, where we are trying to define focus areas which are tackling with these trends here. So this can be summarized in three more or less buzzwords: connected, automated, and electrified. So what does this mean? For a connected, there are some examples depicted here. We can think about a digital twin, which is a digital representation, a virtual representation of a real world object or environment. We have cloud there, we have car-to-car communication, or augmented reality, and such things which are coming. We have also automated driving. Automatization is one of the major drivers of innovation, and also software in the car. We have there things like simple driver assistance functions, as everybody knows, tempomat or adaptive cruise control and such things. But it goes up to level 4, level 5, completely automated driving for at least some dedicated use cases already. So this is, I guess, an important point. And we have also the electrification as one of the big answers to the concerns in terms of efficiency and CO2. Bosch is there active in a broad field of products. Maybe everybody of you knows about the e-bikes, where Bosch is very active. You see on, I don't know, every second e-bike, a Bosch brand on the e-motor there mounted. But we are also there at hybrid vehicles, pure electric vehicles, fuel cells, and so forth. And all those things are also interlinked to each other. So electrification, for example, for a charging infrastructure, needs some kind of connectivity to make, for example, a payment solution out of it. Or the automatization is really relying on high accuracy maps and infrastructure data, which are again provided by a connectivity solution. And what's an overlaying factor about all those things is that software is the key success factor for all those innovations to come. So without software, all those innovations are not possible. They are enabled by hardware and infrastructure, that's clear, but the innovation comes out from the software. And yeah, that's the point where we stand right now. So what does this mean in a more concrete way? I have brought here with me 3 real-world use cases, which are right now under development at Bosch. Those things are presented at the IAA, the Internationale Automobilausstellung in Munich, which took place this year in September, and those things were presented. And we have selected 3 of those. I will give you a short overview on that. First is road signature service. What does this mean? This is more or less a real-time map, a digital twin of the roads out there in the real world. And the data to generate this map is collected via the vehicles which are out there. So all of those vehicles are acquiring data with a huge amount of sensors. Yeah, Mercedes, exactly, great comment. We'll then go into the driverless parking shortly. Yeah, so we have there in the vehicles a lot of sensors mounted, like radars, LiDARs, which is more or less again a radar, but with laser light. We have there cameras, of course, for automated driving, but even such maybe simple things like an ESP, stability control in the brake there, which generates data about the slippage of the road at a certain point. And all those things are then collected as data, then tagged with a date and a location stamp, and then uploaded to a central cloud. And with this centralized real-time representation of the environment, you can generate completely new use cases. So, for example, if your car detects, okay, oh my God, there is a slippery or icy area on the road there, or an obstacle laying around, it can upload this information in the cloud and then provide it via the cloud to other vehicles there in the near, and they can react accordingly. So reduce either the speed or change the route and take another road. So this would be one use case there. A second one is driverless parking. So one colleague's already mentioned it. Mercedes is working on that. That's correct. With Bosch as a partner. This was presented also this year as automated valet parking. So I guess everybody knows classical valet parking, where you hand over your keys to a human driver and then say to them, okay, please be careful, park it on a free parking lot, don't destroy it, and hopefully steal not my car or the content of it. And this is the automated version of it. So you can leave your car at the front of the parking facility and then just press a button in a smartphone app, and you don't need to sit in your car. You don't need to observe the process. The car is taking and searching a free parking lot on its own and driving there, completely automated. And it gives you feedback via a smartphone app accordingly. And to do so, again, you need, at least for this driving situation, of course, a fully automated capability of your vehicle. You need some kind of infrastructure in the parking facility, so sensors, communication interfaces, and stuff. And again, you need something like a cloud to give you, for example, a feedback for the user. And then the third use case I've brought with me here is a battery in the cloud. What does this mean? Again, this is some kind of a digital twin of the battery, and this means the battery data are observed and collected. So things like the state of health, charging state, temperature, charging profiles, lifetime statistics, and so forth. And this is done to monitor the battery, but also to do some predictive maintenance if needed, and to adapt the charging strategies if needed. And additionally, which is also a use case in the Bosch solution there, to generate a usage certificate, so that you, as a, let's say, buyer of a used car, have a clear picture what's already happened to the vehicle car, and to the vehicle battery there, and you have a clear picture how fit the battery still is. You have a Bosch boiler? Okay, that's great. Okay, so any questions on those use cases? Are you fine with that? It's important to understand a little bit, at least, what we are talking about, because we will then step over into the voting. Which one is your favorite use case? And then work with this use case. So feel free to state your questions in the chat. Okay, so I'm not sure if we have any questions. Then obviously everything is clear.
So essentially in this Miro window, to those of you who are in Miro, so at the bottom of the page you have an icon 4 to the left with the chat, and if you open this chat, one can write there and post a question, and we will be glad to answer those.
just use this. Yeah.
Yeah.
Okay, so we have one chat vote for the driverless parking. Great. We have a voting pan here. We'll just switch over to the workshop now. So now we are stepping into the workshop part, and we have a voting tab here. I will just bring everyone to me again. So now we are here. Just follow the arrow here, click on this play button, and then select your favorite use case here. And then we'll do a evaluation on that. Well, we'll see what's your favorite use case is. I just start the timer again so that we have all together an overview. I give you 30 seconds. Please start voting now. So time is over. Obviously, we have some delay in the chat there. For me, it's already over. So Konstantin, how much votes did we get for each and every single use case?
Just give me a second.
Yeah, for sure.
So I posted the image in this board with the results, and we see that
So great. Yeah, sorry.
we got 12 votes, and the winner is Hans.
And the winner is Road Signature Services. Is this correct?
Yes.
Ta-da! Okay, great. So we will work on this. Just a short step back. Road Signature Service is exactly this real-time digital twin for the road conditions we were discussing before. So if you have any questions on that, just ask accordingly. So then I would propose that we switch over to our first MVP canvas. We'll jump there. I bring everybody to me so that you don't get lost. So again, we have the already known procedure. We have here a whiteboard. Oh, sorry. A whiteboard where we will work on right now. And please think about what are features you would expect as a user from this road signature service. What could be, let's say, a basic requirement you expect out of this? And what could be excitement factors out of an UX perspective that you would say, okay, this would really hot stuff to have this function there too. And what could be requirements behind? From a functional point of view, what would you expect? How it? What about the user interface? What about also non-functional requirements like safety or security or other things I might not think of right now? I will give you now a little bit more time to work on that. I will set the timer to 5 minutes. And afterwards, we will collect your comments, your thoughts there, structure it a little bit, and use this as an input for the next canvas. So I set the timer to 5 minutes. And yeah, please start now. Thank you, Manuel, for the picture there.
So essentially, we would like from you to collect your thoughts. What do you think about this use case? What features shall this product have? What requirements to fill in this board with your thoughts? I mean, and just you to post it and summarize what you think about it.
You might also upload images if you have something accordingly. You can also put a sketch on a white sheet of paper and take a picture of it and upload it. So think of whatever is helpful for you. Maybe you can also describe the user interface there and think of how would you expect to interact with the system, or how would you expect to pay for it, for example, or how much would you be willing to pay for it. So please think also on such things. And what would be things you really don't want to see there? So what could be critical points or things they would bother you or which make you hesitate to use the system? So 45 seconds left. Yeah, so maybe you have also some other non-functional requirements like usability or security, which could be worth a thought of.
Just speaking about localization, so if we need to localize a vehicle, to what precision we need to localize? Would GPS be enough, or do we need something else? What is a dimension of to which to a centimeter, to a meter? What should be the range of this localization estimate?
Yeah, and especially for that, also which kind of safety is needed to tackle with unexpected situations or obstacles which shouldn't be there, for example. Okay, super. So time is up. So let's start the running of your work here in this canvas. I would say we walk through it and discuss it shortly. So thank you for your work. Yeah, an alert. I understand it in that way that the system should give an alert if it works, if it doesn't work properly, if it has some problems or issues, or is not able to fulfill the desired behavior. Information on status of car and environment, great. This is exactly one of the main features, so that you get a feedback there to understand if the parking procedure was successful, and where it also to find, and so forth. So the feedback is, I guess, an important issue, also to give the user some kind of security feeling that everything is all right. Voice prompts. Okay, so something, I'm not sure if I understand the comment correctly. If you want to say, okay, you have something like a voice control or a voice feedback there. So something like it was at KIT in the Knight Rider in the 80s back, where we're able to talk with the car with a smartwatch. Now this becomes reality. Of course, this could be combined accordingly. Info about changing conditions. Weather speed limit. That's I guess an important point. We have there an indication to the user where we if there are some changes there, if we have traffic jams is already there, but also icy conditions, obstacles, accidents, and such things, so that you get a real-time information what's happening. Avoidance of constructions or busy streets. Exactly, that goes in that direction, so that we are getting this information. And even more important, when we are talking about an autonomous vehicle or fully autonomous vehicle, then it has to react on its own there. So there is no driver anymore which can guide or control the process. It shall be done autonomously. Easy and funny to use, high usability, good user experience. I guess this is a very important point. We see that exactly that this becomes more and more differentiating factor, also depending on the markets. So when we are talking about, for example, Asian customers, especially the Chinese ones, they are even more eager to work with such a fancy and colorful stuff there as we are here in Europe or in Americas. So it depends also on the market there, what's the expectation of the user is about usability, the interaction of the vehicle and the vehicle systems there with your typically digital environment, so that the car is more and more seen as an extension of your digital world, and you expect that it works in the same way as you are used to at your PC, at your mobile devices, and so forth. And even a connection with the smart home. So this is another digital world you use. And this gives also some hint to the point that we expect finally a smartphone on wheels. Interconnection with the system, but keep the privacy. I guess is a very important point, which goes into security to some extent. So, of course, you could think of attacks you generate there, so that you try to break it accordingly, and change, for example, the routing of the vehicle out of bad reasons. But also, on the other hand, I understand the point there in the context of data security, so that you don't want to be tracked there by some, let's say, background systems where are going exactly and which times and so forth. So I guess that's a very important point, and especially Bosch is there very sensitive, and we are trying to also position ourselves in the market with privacy first. Then what else there? We have the vehicle to infrastructure communication. That's an important point, because obviously it's needed, and this in both ways. So we need a communication from the vehicle, which is, let's say, the data acquisition point, to this common infrastructure, to the cloud there. And vice versa. So if it is up there in the cloud, the digital twin representation of the road conditions, then we also need to bring it back there. So obviously we need a high speed and very reliable and secure communication path between the vehicle and the infrastructure. And it's also mentioned here, it's a great point, vehicle-to-vehicle communication, which is also a possibility, so that you have an instant communication between the vehicles so that they can warn them directly, for example, if there are some things going wrong. Yeah, then haptic feedback, it's a great point. The user-machine interface is a big point we are seeing there. Haptic feedback is great. This is already done for lane assistance and such things. So to have a vibration of the steering wheel, for example. We are also talking about augmented reality head-up displays, which is a very fancy stuff, which makes a virtual picture over a certain object virtually on the position of your eyes. So if you move your head, then a camera is tracking your eye positions and adapt the projection accordingly on the front sheet window that you see, for example, a highlighted person there. So this is really great stuff. We also have for the human-machine interface also things like voice control we discussed before there, or things like gesture control where you interact with your vehicle systems via gestures. Yeah, a great point. Then we also have the weather warnings. Yeah, that's I guess an important point also for obstacles and accidents and so forth. Safety, I guess it was the note there. Safety is very important. You expect that this feature increases the safety and not decreases out of technical complexity or bugs or whatever. That's clear. So the clear expectation from the user and also from the legislation is that an automated system is more safe than a human one. And it needs to be proven, and that needs to be also reflected in the legislation. And this is still a way to go. Then recognize traffic lights. Yeah, that's clearly needed. Failures of technique. Yeah, exactly the point. Availability, reliability is a big point. I had spent some years in the general aviation, and depending on the requirements behind, you have very high reliability requirements, and this goes to redundancy and dissimilarity in the development process and so forth. And I expect that those aviation-based processes and methods will also go more and more into the automotive industry if we go to the higher levels of automatization. Yeah, risk of getting hacked, exactly. This is a security concern. Everybody knows the Teslas which get hacked and then doing some fancy stuff there. And as the systems are getting more and more complex and more automated, this is becoming a real concern. So this is, I guess, very important. And also a differentiating factor, because to make those things up and running is not an easy task. It's complex, but it's possible. But to make it in a safe and secure way, this is, I guess, the high art. Upfront infos about streets, yeah. Alerts, yeah. Oh, this is a small one. Detect obstacles, yeah, exactly. We already had this point. So something else? I'm not sure if I missed something. I don't think so. So thanks a lot for your contribution there, and also for the valuable statements. I think this goes exactly in the right direction. Yeah, so I think we are well prepared for the next canvas, architecture and technologies. So what does this mean? I just bring everybody to me again so that we are on the right board. What does this mean? When we are thinking of building such a system, which kind of technology elements and artifacts would be needed? Think about hardware, software, communication, infrastructure, such things, but also which kind of technology stack to be used? What could be the architecture behind? What could be off-board and on-board functions? And what are also drivers for your architectural decisions? So again, I will set the timer to 5 minutes. Please think about those things and bring your thoughts into the notes or some images or sketches. That clock is ticking. Pause. Ich sorge, dass wir noch mehr verlieren. And also you might think of technologies which are needed for this and which are deciding for these new use cases. So communication technologies, processing technologies, security, safety, redundancy. What do you see as a game changer there?
Also speaking about this road signature service where cars will communicate to the infrastructure and to themselves, what sensors should the cars get, what sensors should the infrastructure get, how the communication might happen, what data shall be stored and how they shall be exchanged between the vehicles and the infrastructure.
Yeah, also think about communication technologies, which can be a game changer there, especially the over-the-air communication. 5G is one example. Maybe there are some others too. And also think about processing technologies, hardware processing technologies, and also software tech stacks, which can be used there. Also, an important point is which functions are off-board and which functions are on-board. So which functions are to be hosted finally in the cloud there, and which kind of functions shall be or must be in the vehicle, just to ensure the safety of the system or to don't rely completely on the communication. But on the other hand, don't drive the costs too high. So if you have too much calculation power inside the vehicle, it might become too expensive because you can scale it more easily in the cloud. Okay, 26 seconds left on my screen. Also think about technologies of the future. So what are the things you expect to come and which could be used there accordingly and make a difference. Okay, time's up here at my screen. I suggest that we step into your thoughts and walk through it. Yeah, so first comment here, LTE. Yeah, great point. So we see there a lot of different communication technologies upcoming. Right now we have LTE and other, let's say, classic mobile standards which are used for the communication between the backend and the vehicle itself. And the backend might be a generic one, or it might be also a car manufacturer specific one, depending on the use cases there. And LTE is one of the things used, so it's already common that new vehicles are equipped with an over-the-air communication unit, also with a SIM card accordingly. And it's expected that with 5G, we'll see much more bandwidth and also real-time behavior of the communication as we have it now. Operating system in cars, also a very valuable point. It's broadly discussed right now. I'm not sure who of you is aware of the actual discussions we have also in the media there. For example, for Volkswagen. Volkswagen has founded the CARIAD, their software unit, as a separated company. And the mission statement of CARIAD is that they want to introduce their own operating system into the mobility ecosystem. And operating system is then not only meant as a pure scheduler. It's really seen like an iOS or something like that. So a middleware and a software platform, which is then used generically to host functions, to be the center point of the ecosystem there, and provide the possibility to third parties and suppliers and who else to develop their own apps and integrate it there. So operating system is a very important point. And from technical point of view, we are going to see more and more Linux-based operating systems and applications there, POSIX-based. We have there, for example, Yocto-based systems or other things. And we have also, especially in the infotainment domain, now a trend going towards Google Android. Android is also having an automotive branch of it, and this is coming more and more into the vehicles. Yeah, protocol for car-to-car communication is a very good point, especially for this direct communication. This is not done via an infrastructure, so you have to use different methods there. I'm not an expert on that, but I know there is some standardization discussion ongoing, and there are communication standards based on, let's say, wireless technology in discussion, but also light-based ones with laser light. So this is, I guess, still a field to be developed, and something which needs to be worked out. Then the interface between man and machine. We also had discussed this. Human-machine interface in different ways. I guess very important point. API for maps. Also a good point. So when you are providing map data, it's important that the vehicle functions and also the cloud functions can work with those generic data accordingly, and that you have generic interfaces there. Map providers like HERE, for example, which is was a subsidiary of Nokia and also bought by then Mercedes-Benz and BMW, are providing exactly these things. Yeah, what else is needed? Yeah, a clear vision. That's really true. Infrastructure on the roads, that's also needed. At least you need some kind of connectivity, but it is also helpful to have some data points or position points which are used for the exact and even highly accurate localization of the vehicles, which are providing a dedicated GPS position on a certain point, and this is used to correct the GPS signals and to realize accuracies in the centimeter area. Best developers, really true. I guess the developers are the heart of all those things, and are the brains and the hearts of this transformation, which is ongoing. And also agile team. We need agile working methods and collaboration methods with all the partners in the ecosystem to realize those things. So thank you for that. Thank you for your collaboration there. Let's move to the next step. Yeah, risks and challenges. I just will bring everyone again to me. Now I would ask you to think about what could be risks for implementing this, what could be challenges, what are the things we shall think of, we shall consider when we are going to implement such things. I will give you now a little bit less time, maybe 2 minutes, and then we can walk through it again. Also, think about what could be also collaboration models between the partners, how to deal with the IP generated, and yeah, also how to work together there with different partners, how to set up such an ecosystem. Clock is ticking.
Also, regarding the technical point of the MVP, for instance, if we use a kind of a sensor, and for instance, let's say it's a camera, then if we have different lighting conditions, how do we substitute the sensor data? How we still get the information? What are the means, for instance, to increase the reliability of the system? How can we approach this? What can be the challenges in this way?
Also think of things like open source. What would this mean if we use open source software stacks there in the context of the collaboration model, but also having an ecosystem behind, a crowd which is working with that? What could be the advantages, disadvantages of such an approach? What would you prefer? Okay, so time's over. I'm not sure if somebody else is still wanting to make some comments. Please feel free to do so. I guess we can walk through it shortly and think of your actual comments. When something goes wrong, whose fault is it? Yeah, exactly. That's one of the center questions we have there. Also in the collaboration models, we see there in these new ecosystems. So we have the OEMs, so the car manufacturers, let's say the spider in the net in the middle there. But we also have suppliers like Bosch. We have third parties which are providing things into this ecosystem, like an open source operating system or other software artifacts. And that's exactly the point. Who is finally the guilty one if something happens? So who gets the blame, let's say, if we have some problem there in the development process? But it goes also beyond that in terms of liability. So if we have there a safety or security incident, who is responsible for that? Also in a legal way. And this is one of the big open questions, which is actually in discussion also in the industry-wide. and there are now a lot of different approaches tried out. And this is also a very interesting point, and also a very interesting phase we are right now, because the complete industry is developing more and more into an ecosystem and platform-based one, and this is a very interesting journey we see right now. But yeah, it's a great point. Thank you for that. Okay, what happens when there is an accident between two or more self-driving cars? Okay, also great. Goes into the same direction. We have the legislation issues, of course. The legislation is, I would say, still a little bit behind behind the actual state of art. We have there in Germany, especially, quite good legislations, as well as in California, for example, in the US. But still, such questions are still to be discussed. It's also a legal question, also an economic one, because whose insurance will pay for that, and how to find out who is finally responsible for this accident. So is it the car holder? Is it the manufacturer of the car? Is it a supplier of a sensor or of a computer, or what else? So this is still an open point. And I think this will also be some analogy to the aviation industry, where the same questions are there, because autopiloting and such things are very common there. But still, you have this point of a final responsibility there, and that's to be defined. Yeah. Great point. Thank you for that. How to manage regular cars and self-driving cars on the same road? Also a very good point, especially if we assume that the driving behavior of a self-driving car is more defensive as a regular car. Also, depending on the country you are driving, it might become that the human driver is aggressive and might give some defense self-driving car some disadvantage in the traffic flow. It's a good point, but also again, how to deal with that, how to indicate to the drivers, the human drivers, that this is a self-driving car and not a human one. This is a good point. How to deal with getting hacked? Yeah, that's a security stuff. Again, so how which kind of incidents could happen, which kinds of attacks are critical ones. And I guess there are a lot of things that can go wrong there or could be misused. That's clear. And again, how to deal with is, okay, what could be countermeasures to avoid this? What could be countermeasures if such things happen? And how to react as fast as possible there. And for me, it's clear that we are going more and more towards let's say consumer electronics-based approach, where we don't drive the car out of the manufacturing plant, and then it's in the best state, and then it degrades more or less till the end of the lifetime. No, the car shall become better and better after the production. And this is done via updates over the air. And especially for security incident, this is not only to have a feature enrichment and to generate a new revenue stream to the car manufacturers, it's also to deal with security or safety incidents. So I guess you will be forced in future, also by the legislation, to be as fast as possible to make security updates, for example, for your self-driving vehicles. And to allow this, you need the connectivity, you need a central, let's say, configuration management of the software in the vehicles there, and also the possibility to deploy it as fast as possible. Meaning, on the other hand, in the back end, you need to develop your software and also validate and verify it as fast as possible. So this means also DevOps and continuous integration is needed there. Yeah, malware, ransom software goes exactly in the same direction. So how to deal with that, how to authorize and authentify the software which is downloaded in the vehicle and finally executed there. Yeah, technical hiccups, camera failures, etc. Also an important point. Again, I know it from the aviation industry, where you have a pre-flight check before you start your flight. You have to check all the systems, and you have to check that those redundancy systems are working properly, so that you can avoid dormant failures before your flight start, which might be then critical if they are detected during flight. So I expect that those are some self-checking mechanisms and things of a pre-drive check are necessary and will also be asked from the legislation there. Yeah, so I'm just looking if we have some other comments too. I think not. Yeah, I think we are through with that. So thanks a lot for that. There were a huge amount of valuable points and statements there. We now want to give you also the opportunity to ask some Q&As. So please use the chat function Miro accordingly, or also if you are interested in please come on the live stage here, use StreamYard, just click on this link here next to duck, and then you come also on the live stage and we can also have some audio discussion. So please feel free. So how far away are we from these self-driving cars? It's a good question. It depends on the use case. So if we are talking about self-driving, I would say more generic vehicles in a dedicated and controlled environment, like an airport or logistics centers, Habers, I guess in Hamburg, such a system is already in use, or also manufacturing plants. This is already used there. So Konstantin and Manuel, they were working on Sinotrack, which was dealing with automated forklifters in logistics and warehouse applications. I guess it's working there very, very good. And we are already there that we can have completely automated vehicles in such environments. If we go more and more into the real world, and the real world, as we all know, is very complex, then it's becoming more tough, because then we can have much more unexpected situations and obstacles and things happening, and then it becomes more critical. So even there are some differences. When we are talking about standard highways, then at least we can assume, okay, we have a controlled environment, no playing kids there, no animals on the road. Hopefully, all the vehicles are driving in the same direction with some clear rules. This is much easier than driving maybe in the rush hour in Tokyo or in Calcutta. So it depends also on the environment we are talking about. And going more and more into this real world use case and in the chaotic use cases, I guess then it becomes more and more in the future to have this in reality. But to be honest, I expect that we will see at least semi-automated use cases on the highways in 25. So Mercedes, for example, is working on such things, at least level 3 automated driving. They are already introducing there. And especially for those things which are commercially interesting, we'll see this also from my point of view in logistics. So a hub-to-hub automated driving from commercial vehicles and heavy-duty trucks over the highways is, I guess, something which is not a complete science fiction to have this in some years. But to have a completely self-driving car driving you from here to there to completely different driving situations, I guess this is still a decade to go.
So from my side, to add to this question, I think 5 years ago or so, people were much more optimistic about this, and it's easy to make 80% done than 100% done. And this last 20% is very, very hard to do. So that poses enormous challenges. For instance, take traffic sign recognition. Okay, one can take a convolutional neural network, train it, has about 90% accuracy, great, but then one could have manipulate this traffic signs slightly, and then you get a different response. And the network you are trained essentially is a black box. And then there was this movement to do this white box learning, to understand actually what one can change to come to this result. And I think now we are more aware about these challenges, and there is still work to do. And yeah, but that's from my side.
Yeah, thank
So
you, Konstantin.
there is also a follow-up question, Hans. How do you think different countries will manage to provide the possibility of driving autonomous legal regulations?
Yeah, that's also a very, very good point. I see a huge interest also from political side to enable those things. So Germany has released, I don't know, 1 or 2 months ago, a very liberal law for the regulation of autonomous driving on public roads. So this will be a catalyst for the development there in the European Union and Germany especially. So they have high interest in that. Also, California is very tough, and also China. So I think all the leading regions have recognized that this will be one future market and will be a huge one. That's completely clear. And also seen out of the mega trends we have discussed before, it makes much more sense to have autonomous vehicles which are as much as used as possible out of an, let's say, resource consumption perspective. And also to overcome a little bit the parking lot problems in overcrowded cities and such things. And of course, there are also economic benefits there. Also, as we discussed before, to include disabled or elderly people in the mobility process. So there are a lot of use cases which are also out of political interest. So I think this will be also supported by the governments. But still, of course, there are different approaches. And as Konstantin mentioned before, for the training of an AI system, you need data. And the question is how liberal is then the data law there, how to deal with that and so forth. And to be honest, I see China there right now as a front runner, at least at that perspective.
So also via the streaming platform, we have a possibility to have a voice discussion. Then we would encourage you to join via this StreamYard link, to join the stream and to have a conversation if you have some questions.
So what is the biggest challenge? I'm not sure if it's possible to name the biggest one. So legislation and such things we have already discussed. There are also clearly economical challenges, which are also critical ones. And from technical point of view, we will have a short look on those challenges also later on. There are some slides upcoming for that. Does it need new levels of security as well? Yeah, for me, clearly. So the classical automotive system was a closed one, more or less, with proprietary software and no possibilities of over-the-air update and so forth. Now it's becoming an open ecosystem, like a smartphone. So therefore, we had this analogy used for the title also there. And that means we have there this need of new security algorithms. And even also, let's say, innovational disruptions are also in discussion already. So I know that we are working on post-quantum cryptography. So if we assume that quantum computing will become a thing out of science fiction into reality in the next years, then we also have to think about the security of our algorithms. Yeah, and so out of that, maybe it is also out of interest for you. Everybody who is able to deal with those challenges, to understand the safety concerns, to understand the security concerns, to deal with a tech stack, with a complex one, in this context here, to understand communication technologies, have excellent perspectives in the automotive industry. And all of those things are clearly based on software and software know-how. Okay, so there was another question. I think a good possibility for that is to have car sharing. Yeah, like public transport. I have the same imagination there, that we will use this also as an additional alternative path for common public traffic, that you can order your automated taxi or car, whatever, and which bring you from here to there, which is, I guess, a comfort issue, but also a kind of usability, especially in rural areas or something like that. I guess this will be the future. Yeah. So thanks a lot for the questions. It was a quite interesting talk with you. We had foreseen a coffee break, but to be honest, we are a little bit running out of time. So I'm not sure if you need it. Maybe you can give us a thumbs up if you say, okay, we are fine with, and we can do the last half an hour for the workshop without the break. If you need a break, then please send a heart. Then we know that you need some kind of a break there. So it's up to you. Please give me an indication there. So are you fine to proceed without the break?
Yes, I mean, the chat people, some people write that they don't need break.
Okay.
So, and also they said that ignoring, so there was also a question, ignoring technical progress or constraints, how long do you think it will take for regulations to allow completely self-driving cars? I mean, it's a different, it's a difficult question, and to be honest, I, for instance, is the wrong audience for this, but it all depends on the state. I mean, in California, the regulations are much more loose, and there are some places on Earth where one can test it, which are already have the regulations in place. And in some other places, maybe it will take decades. Yeah, so it's really hard to answer. And I don't know, Hans, if you have something to add to this.
Yeah, completely agree with you. So I guess there is no generic answer on that, and we have there, regulation, but also economic barriers still there. But I guess it will come, and it will come for some dedicated use cases first. Okay, in Europe, I think the European Union has understood that this is important. They are working on that. But if we see it, let's say, in a broad usage, we'll see it. I guess my personal opinion, it's not an expert statement. Here is, let's wait a decade till we see it completely and used there in a broad range. But as mentioned before, we will see some dedicated use cases much earlier. Okay, so I would propose that we step over to the next point. So, sorry. And we will have now the possibility to wrap up those things a little bit and have a short look at the future challenges we see there. So the question was also before, what are the things which are challenging for us in the architectures? I will walk through it shortly through that circle. First of all, functional complexity. When we are talking about the new functions, especially self-driving cars, the new infotainment stuff and so forth, the colleagues, our experts expect that we are having 100 times more software as we have it today in the cars. So the self-driving vehicle will become the most complex software product on planet Earth. So this is, I guess, one important thing to understand, that we are seeing this as one great challenge. Also, how to deal with that in terms of efficiency, setup of development and collaboration, infrastructure, and so forth. Scalability is also an important thing. We have to think of solutions which are, let's say, economically making sense for small cars as well as premium cars, and different use cases we already discussed there. I guess that's important. Communication bandwidth, we already discussed it for the over-the-air interface. We see the same in-vehicle communication when we have cameras which are creating a huge amount of data per second. We need to deal with that also inside the vehicle. So Ethernet is coming into the vehicle, PCI Express, and some things beyond it to tackle that. Computing power. That's also a very important point. We see there, especially for AI algorithms, computer vision, and so forth, the necessity to have hardware accelerators in there, because classical approaches doesn't work anymore. External communication security, I guess we have already touched this. Flexibility, introduction of new innovations and software sharing. I guess over-the-air updates and the necessity of it, we already discussed it. I want to move over now to the next point. What does this mean for technologies and methods? Maybe Konstantin, you can give us a short overview on that.
Yeah, thank you, Hans, for giving me the opportunity, and let's talk about this. So we've just seen the challenges that Hans presented, and the only way to tackle the challenges is to use a combination of cutting-edge technology and state-of-the-art development methods. So, and this is this conceptual division of the slide. The technology is what shall we use in order to successfully tackle the challenges, and state-of-the-art development methods is how should we approach this. So let's talk about technology first. So on the bottom, you see the microchips, the MIPC and MIPE. So MIPC stands for microcontroller and MIPE for microprocessor. And we definitely see that in vehicle computers of the future, one will find both microcontroller and microprocessor, since they have very different properties, which is especially relevant for automotive. So microcontroller is running hard real-time operating system, time-triggered computation, predictable deadlines, integration with sensors and communication buses, and the microprocessor runs Unix-like, maybe a variant of Linux or QNX operating systems, which hosts some compute-intensive applications, say computer vision application like lane detection, Hall transform, or a convolutional neural network for detecting traffic signs, obstacles, or driver fatigue. So that's what we spoke also before. So speaking about microcontrollers, they are shown on the left of the picture. So they are by far the most advanced devices, the microcontroller devices. They have up to 8 cores and they run on hundreds of megahertz frequency. They are capable of virtualization, which allows to run multiple OSs and software stacks parallel, just like virtual machines on the PC, but on the microcontroller settings. And these settings is quite very different. So software on the microcontroller has a layered architecture, and it consists of low-level peripheral drivers and hardware abstraction, which is called BSW in this picture, and this stands for basic software. Then there is a middleware, which is shown in red, and this is the so-called runtime environment, or RTE, and on top runs the applications or apps, which is shown here. So one can also group the applications in a cluster and update them separately. And in the microcontroller setting, it's also a challenge to do this update because everything is linked statically with absolute addresses. So the amount of computation is also growing very rapidly. And it's often the case that in a car, the vehicle computer of the future would be not just one computing unit like one microcontroller or one microprocessor, but several devices, a combination of both, which then creates a heterogeneous systems and needs a high-speed communication, and that's what is shown also the communication between the MIP with magenta and cyan lines. So in order to master this complexity and being able to create tangible outcomes throughout, from the first prototype to the serious production, one needs to have a working setting where one can clearly focus on the problem, have priority set, and have a possibility to continuously improve throughout the process. And that's where we see that the agile and also elements of extreme programming or XP can be leveraged and actively used also in our group. Yeah. So it's also very important to have continuous build, continuous test, continuous deployment, and that's why we emphasize this separately and use state-of-the-art development tools in order to make the cost of a change of the software as low as possible. Yeah. So that's from my side.
Thank you, Konstantin, for the insight there. Great. Yeah, the next step is, or what I want to present to you shortly, is the EE architecture evolution. EE stands for electronic architecture in the automotive industry. So the components inside the vehicle, their communication structures, and the functionalities hosted by them. And what we see here is a classical domain-based architecture coming from powertrain, chassis, and so forth. So the functions are the sorting criteria for that. And with the new architectures, with much more computational power, we see more and more centralization of those communication power into central vehicle computers. And these central vehicle computers are then more or less the brain of the complete vehicle, and the embedded systems are, let's say, the arms and legs, which are then acting accordingly in the physical world. What we see there is that the different car manufacturers have different paths to this vision there, and also different speeds. But it's clear that all OEMs in certain different solutions are going in this direction. And when we see this architectural change, this means taking Conway's law into consideration. I jump to the next slide there. That this means also we need to adapt our organization if the architecture changes. And this is what exactly happened at Bosch with the foundation of XC. XC stands for Cross-Domain Computing Business Unit. So the X and the C, and Konstantin and myself, we are a part of it. And this unit was founded with the beginning of this year. So, and the main intention was to have this cross-domain collaboration also established internally and to deal with the development of this new EE architectures in a proper way. Yeah, so this brings us to the next point, part 4. Our touch points. And I want to give you a short introduction of Bosch, just to give you some hints where we are there and what Bosch is doing else. So somebody mentioned the water boiler before. So then you are here in the consumer goods sections. I guess you might have also some other household appliances from Bosch there, your dishwasher, your washing machine, your vacuum cleaner, or a lawnmower, or what else. Drilling machine. So I guess Bosch is well known for that. But the biggest business unit is the mobility sector, and XC is a part of it. But we also have industrial technologies there. Bosch Rexroth, which is also doing industrial automatization, but also, for example, alternative energy stuff and so forth. And we have also energy and building technology there. With heating systems, so Buderos and Junkers, for example, are brands of Bosch finally. And we have a very strong R&D focus, research and development, and we have over 70,000 developers at Bosch, and over 30,000 are software developers. And those are located worldwide and really worldwide on all continents, 129 facilities over the world. And one of those is Vienna. And even we have an XC in Vienna, and maybe Konstantin, you can give us a glance overview what we are doing here.
Yes, thank you, Hans. And we are fortunate to be part of the cross-domain computing XC in Vienna. And on this slide, I would like to show you all what's our focus of the Vienna software team is. And to say it in one sentence, you see the blocks colored with different colors, and our focus is everything which is not colored in gray. So everything which has some different colors, yeah, so that's our focus. This might, of course, change in the future because the division is rapidly growing. And let me start from the bottom part of the picture. And what's most important for me is doing prototypes on new hardware. And we are fortunate to have access to the hardware because it's cutting-edge hardware technology, which is even not available in the public market. And it will be in cars maybe in 5 years. So, and we have a chance to work with this technology here. And for the prototypes, colleagues of ours are working on high-speed multi-chip communication, which we saw on the slide before, that it's important to create new weekly computers with multiple controllers. So the low-level software is another focus of XC and Vienna, and this low-level software should allow customers to build their own software stack on top if they need to do so. Also, virtualization on the microcontroller, which allows run multiple software stacks, which one is colored in gray and one has a different colors, green and red and all this. And the software stack in this microcontroller setting in automotive, it consists of 3 parts. And it has a special name in automotive domain, and it's called Classic AutoSAR. And this is an open standard. And our colleagues also work on extending this standard and doing corresponding implementation for features which would allow flexible software updates. So to recap, in Vienna, we have a lot of interesting topics and challenges to work on. Yeah, that's from my side.
Great, thank you, Konstantin. Beside that, we are not only working on XC-based topics, we also have other mobility solutions here too. So XC is depicted, but we have also a classical engine control unit business here, hardware software development. I guess Peter has it explained before a little bit. And we have cross-domain computers, vehicle computers, which are powertrain domain controllers. And we have also inverter and converter development. These are high voltage, high power electronic units used for electric vehicles. Also hardware and software development here, as well as some validation stuff. We have an EMC lab here in Vienna, which is the leading one in Bosch Europe. And also some validation facilities for high temperature and low temperature test and so forth. So we have a complete bundle of different development services here for different products and areas. Yeah, so what could be your contribution, and which kind of team would you join if you are interested in? So we have here colleagues with a technical background, obviously, in software engineering, computer science, also classic electrical engineering, technical physics, mathematics. So it's a broad variety of background knowledge we have here, and it's also needed. You have seen the tech stack before from Konstantin, and yeah, therefore we also have different kinds of experiences and backgrounds here. But this is not the only point. It's deep in our DNA to be also excited about the mobility of future, the things we were discussing today, about innovations and really leading edge technologies. As Konstantin mentioned before, we are working on the things which will be in 5 years and more on the streets. We are also proactive and hands-on personalities. We like to try things out, to do it, to see if it works, go into the car, see if it works in reality. we also try to be open-minded and think beyond borders. We have seen before that we have decentralization. We have to have more collaboration beyond the business unit borders, even company borders. We have to become more open, and I think this is also part of the culture here. And last but not least, we are very diverse. Even in our team, I don't know, we have 3 or 4 nationalities right now. And also we are collaborating with people all over the world. So we are open to other cultures, other backgrounds, and we like team play. So these are, let's say, our values. And yeah, if this also fits to you, it would be great. If you are interested to join us. And yeah, if we can have deeper interaction with you. So I think we are through with the content there. Thanks a lot for that. We are going now towards the checkout. We are having now a checkout section. And I want to ask you some questions. And these questions would be more or less a reflection of today. So what did you enjoy today? What was convenient to you? What did you like? Also, what did you learn? What was new for you? Surprising maybe, or something you take with you? And then also just one short feedback, also the workshop in one word. So I would be happy if you can use again our boards. We have prepared for that. Here our checkout board. I just give you 1 minute. 2 minutes to walk through the questions there, and then we can maybe walk through it together and collect your things and reflect today's workshop. So the clock is ticking.
So it's 2 minutes per one question, right, Hans? Not 2 minutes for all the questions.
So it depends for me. Let's see how much is there. If we need some additional time, of course, we can expand it. So I think we are more or less through. So I would say let's have a look on your comments. I'm curious to see what did you enjoy today? The insights. Okay, thank you. So then we have followed up one of your expectations you have phrased at the beginning of the workshop. Thanks for answering the questions. That's the reason why we are here. Of course, we are there also afterwards for you. We'll share also our contacts with you. This is the next slide. Then it's a little bit small for me. Thanks for the really interesting session. Nice preparation. Thank you also for the feedback. The insight. Yeah, this was our main intention here. Thank you for that. What did you learn today? I gained some insights on future and the future of mobility. Okay, great. This was exactly the intention. How the future will look like. Yeah, and the future will be, I'm really optimistic of that. It will be bright and glorious, at least for the people who understand it, who can deal with it. For software developers, I see El Dorado coming. So it's a great future. We are heading into interesting future with lots of challenges. Yeah, exactly. And where are challenges, there is a possibility to make out of the problems opportunities. And I'm really convinced of that. We will do so, and this will be a good future. Thank you for that. Jaroslav, are you trying to note something down? Okay. Then the workshop in one word. Amazing, thanks. Okay. Also, thank you for that feedback. Great that it was fun for you. Educational, so great, you have learned something. Yeah, great. I also can say it was a great workshop. Thank you for that. It was a pleasure to work with you on those things, to have those talks, this exchange. And to be honest, I'm really impressed by the depth of your feedback there, and also the comments and statements you have created. I guess this goes exactly in the direction where we are heading for, and the things which will happen there. So thanks a lot for that.
Yeah, thank you also from my side. I also want to say that for us, it's the first time to do the workshop in this format, and we also learn a lot from how it goes. Yeah,
that's really true. And if we have the chance afterwards in the afternoon session to meet us personally, I would be happy about. Konstantin and myself, we are here in the Geierstraße facility, and we are here for you, also for your questions and to have some talks with you. I'm also at LinkedIn, so you may also contact me via this channel, or also contact our colleagues from HR if you have some further questions there. Yeah, so for me, it's time to say thank you. If you need some more information there, we also collected some stuff here. So if you want to see some like a Bosch movies, and also, for example, a nice and funny video for automated valet parking, one of the use cases we have discussed today, there is a lot of on YouTube available. But we have also some technical background and deep dive material, which is open for you. You can have a look inside to see more details about the things we have discussed today. And yeah, then this could be also one point to get deeper into the topic there. Yeah, so we are now through with the workshop. Again, I have to say thank you. Thank you for the interesting discussions and your interest. And also thank you to my colleagues, Konstantin and Manuel, which supported here and prepared together with me this workshop, and also supported here during this workshop. Great. Thank you for that. And I'm looking forward to meet you afterwards during this WeAreDevelopers event inside this day. Okay, then thanks a lot. Thanks a lot for the workshop, and it was a pleasure.
Thanks also from my side, and enjoy your WeAreDevelopers Day at Bosch.
Great.
Hello, everyone. Hello, Hans. Hello, Konstantin. I hope you had fun. I'm sure the audience had a lot of fun. There was so many useful information, very intensive, but as I said, very insightful and useful. So thanks, Hans and Konstantin, for hosting this workshop. We are already here at the venue where we will actually welcome you if you are joining us in person in Vienna. From 1 p.m. we are starting, but check-in is already starting right now. So hurry up and join us here in person, or join us at 1 p.m. sharp also online if you are joining us from all around the world. So we have the last technical checks here with our speakers. We have a nice and cozy setup here. We have, very important, something to drink, something to eat, and last but not least, we have popcorn, and also there is some other cool drinks. So with that said, I would say enjoy your break. See you in around 1 hour again, and see you then. Bye-bye.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.